Hello, this is Dr. Dominic White from George Mason University, and in this video I want to talk about version control and version control systems such as Git. In CDS 101, we are using Git, which is an example of a version control system. Version control is just a fancy term for a simple idea. When you have a collection of files or other information, you often want to track the history of changes to those files. You might already be familiar with version control. For example, Wikipedia tracks every edit made to each of its articles, which is a useful feature for seeing the changes in information over time. On a more personal level, word processing software like Microsoft Word allows you to track every change made to a particular document, along with who made it and when. There are a number of reasons why we want to use version control, especially for programming projects. As we record the changes to a project, we build up a picture of the entire history of that project. This is useful for complex software projects that evolve over time with hundreds or even thousands of contributors. If we make a mistake in the project, we can easily revert back to a previous point in its history. If we change our strategy for the project, we can try out this new approach in parallel with the existing version, without overwriting any of our progress. Version control makes it easy to compare versions of the same file and see what changes have been made, and many version control systems also function as a backup of the project's files. Finally, one of the most important features is that it allows multiple people to easily collaborate on the same set of files without the project descending into complete chaos. So how can you version control a project with Git? Fortunately, RStudio takes care of much of these details for us. However, the basic outline is as follows. Git has to be initialized to start tracking a particular folder on your computer. This folder and all its contents then fall under version control. When you import assignments into RStudio from GitHub, this process has already started. Git has to store the project history somewhere, and so it creates a hidden folder inside the main project folder. This hidden folder will have the name .git, and it is called the repository of the project. Editing or deleting it can destroy Git's record of the project history, but fortunately most operating systems hide this folder from us. I'd recommend steering well clear of it if you happen to see it. Git is what is known as a distributed version control system. It was explicitly designed to enable multiple people to work on a project together, so if you share a Git project with another person, their version of the project will also include the .git repository folder and all the historical details that are stored in that folder. So that's how Git stores the history, but how does it decide to create it? You work on the project as you would for any files on your computer. You make some edits and you save them to the hard drive. However, Git does not record the history automatically when you save the file. There is an extra step that you must do. After making some changes and saving them, and this could be a single character or 1,000 lines, you then have to explicitly tell Git, okay, take a snapshot of the project at this point in time and save it in your repository, please. This process of taking a snapshot of all the project files is called committing the project. There are two steps to making a commit. First, you have to stage any updated files that you wish to commit. You do not have to stage every edited file. However, any unstaged files will not be included in the next commit. In the Git pane in RStudio, you will see a checkbox next to any file that can be included in the next commit. This is why, if you forgot to click that checkbox, the file was never committed. Second, you make the commit. Git takes a snapshot and stores it in its Git folder. This snapshot includes information about when the commit was made and who made it, as well as a complete copy of every file that was changed.